In this video, I'm going through energy, which you can probably guess is physics related. Now, energy, right? What's so great about it? Well, it cannot be destroyed. It's usually transferred into another object's energy stores. Now, there are 8 energy stores you should know for the AQA GCSE course, okay? And that is thermal, kinetic, gravitational potential, elastic potential, chemical, magnetic, electrostatic, and nuclear energy stores. When a system changes, now system is just a word for an object or a group of objects that we're interested in a particular amount of time. Now when a system changes, energy is usually transferred. So, for example, if you're boiling a kettle, that heat is going into the kettle, which is then boiling up the water, which might turn into a bit of kinetic energy. So talking about energy, there's 3 equations, well there's loads of equations related to energy, but there's 3 equations related to the types of energy. There are the equation related to the kinetic energy equation, there's the elastic potential equation, and gravitational potential equation. The equation related to kinetic energy equals half mass times volume squared, right? So if you write that out, you'd write that out as like E with a little K next to it. That stands for the kinetic energy equals half of mv squared. M referring to mass and v referring to speed. So with that, you then get your kinetic energy. Now the equation for gravitational potential energy, which I mentioned earlier, gravitational potential energy equals mgh, which is mass times the gravitational field strength, so on Earth that's about 9.8, or some people just refer to it as 10, but 9.8 accuracy, times height. So for example, you'd take the mass of an object, so let's say I had like 1 kilogram, and I pulled it up by 1 meter, that would be 1 kilogram times the gravitational field strength, 9.8, times 1, which is 9.8. The elastic potential equation, I've got it written down here because this is one that I should probably know, but I haven't exactly got it into my head yet. The elastic potential energy is E with a little e, that's the elastic potential, equals half Ke squared, that's it, half Ke squared. Now, K refers to the spring constant, and, well, the E refers to the extension of said spring. So, you can probably guess from there, how you'd work out, you do half of the spring constant times how long it extended by, and you then put that into the equation. Science. Now, still on the energy topic, we have this thing called specific heat capacity. Now, that's a big word, and if you don't know what it is, then you're probably thinking, oh my god, it's going to get really complicated. It is not complicated. Specific heat capacity is just the amount of energy it takes to raise 1 kilogram of a substance up by 1 degree Celsius. Now, the equation for this also looks pretty intimidating, but it's actually really simple once you get your head around it. The equation related to specific heat capacity is delta E equals mc delta theta. Now you're probably thinking, what does that mean? And you'd probably be right. What does it mean? And that's why I'm explaining to you what it means. Now, delta often refers to the change in when it comes to physics. Like, acceleration means delta v over delta t, that's the change in velocity over the change in time. That's for a future video. E refers to the change in thermal energy. That's what you're working out. Anyway, the equation goes mc delta theta. Now, m would refer to the mass, and c refers to the specific heat capacity. And, well, delta theta, we're looking at temperature, and delta the change in temperature. Theta often refers to angles in mathematics, but in this equation we're looking at the temperature, because specific heat capacity. Moving on to power. And no, we're not looking at an Old Spice commercial, we are looking at the equations. Now, in this case, power is watts. Watts will be, let's say, the equivalent to 1 joule of energy transferred a second. You can actually use equations to calculate power. One of them is P equals E over T. Now P refers to power, E refers to energy, and T equals time. Time, usually seconds. P equals W over T. Time still refers to seconds. However, the W in this case refers to work done. That is covering the start of energy for you, if you don't know what energy is. So, a recap of the video: basically, energy can't be destroyed, always transferred. I told you what the 8 stores are: thermal, kinetic, gravitational potential, elastic potential, chemical, magnetic, electrostatic, and nuclear stores. Those are the 8 ones you need to know. I talked about the equations for kinetic, gravitational potential, and elastic potential, and also my favourite actually, specific heat capacity. Loved learning what delta meant through that, and theta, and all those great Greek alphabet letters. Yeah, great. Good on you, physics, using Greek alphabet letters, because who doesn't love that? You know, we throw in a bit of rho for, you know, density, and we throw in whatever that is for wavelength. That is physics. We've just touched on some of the energy. In my next video about energy, we're going to look at conduction and convection and all those other wonderful juicy goodness in energy. And this is just topic 1 in the AQA course for the physics which I'm doing, okay? That's just topic 1. We've barely scratched the surface, I tell you. We just got up to, yeah, conservation of energy and power. We've got conduction and convection next. Reducing unwanted energy transfers, believe it or not. Efficiency. Oh, we're getting wind, solar and geothermal energy up in here. Let's go with those renewable resources. Anyway, I hope you guys have enjoyed this video. I hope you've learned something as usual. As usual, this is one of my first videos. I haven't done this before. Anyway, I hope you've learned something, and I hope you can take something away from this video. And if you didn't, leave in the comments below what you want to learn about. If you want me to cover anything that you might be stuck on, if you want me to try and explain something as well. My explanation may be rather quick and stuttery, but I think you get the gist of things. Leave a like and subscribe if you want more revision-based videos. Of course, as I said, this is, as I said in my introduction, this is revision for me as well. Like, as I said, I don't know the elastic potential equation off by heart, but for this video, E, little e, which is the elastic potential energy, half ke squared. Boom. Revision for me, and it's a revision for you. You should be jotting down notes. Boom, yes. Elastic potential is half ke squared. Be writing that down in your notebook for future use. Revision cards, all that juicy goodness. Hope you guys have enjoyed me just embarrassing myself for your sake and a bit of mine. See you in the next video, guys and gals.